explicit formulas are very useful because they allow you to jump. And that's basically the big thing here. It allows you to jump. Allows us to jump to any term. Now this can somewhat be difficult to master. We're going to do our best. Okay, what I'm going to suggest is that you label these as term numbers. So term 1, 2, 3, and 4. What's happening? That's the first question you need to ask yourself. What's happening?
You're increasing by 4.
Increasing by 4 every time?
Yeah.
What number are we starting at?
-2.
Starting at -2. Increasing by 4, right?
Yeah.
So let's say I wanted to go from term 1 to term 3. How much am I adding?
8.
8. How far do you add? I mean, that's really 2 terms, right? You're adding 8. Okay. Well, here's some ideas out there. What are you guys thinking? Keep running some ideas. What can we do? What kind of manipulations we can do? Okay, let me ask you this. So we're increasing by 4 every time, right? Yeah. Anytime you're adding or subtracting, easiest way to do that is to take that value and multiply by n. So since we're adding 4, it's going to be positive 4 times n. That's the beginning piece. We're not done. Beginning piece. And this is one of those things where you're going to constantly have to give and take. Make fine adjustments.
Wait, why did you? That'd be so you'd be multiplying instead.
Yeah. Now watch what happens. What's 4 times 1?
4.
Well, what are we supposed to have? So how do we go from 4 to -2?
Subtract 6.
Okay, so let's subtract 6. That's our adjustment we're going to make. Did you guys see how I made that adjustment? Okay, now go back and verify that this works for all the terms. What's 4 times 2?
8.
Minus 6.
-2.
What's 8 minus 6?
2.
Is that a match?
Yeah.
Okay, let's check it for 3. 4 times 3? 12 minus 6. Does that match?
Yeah.
There you go. That's your explicit formula.
I understand how you figured that out.
Okay, do we need to kind of go over how we got that again?
Yeah.
Okay. All right. What you do is you take whatever you are increasing or decreasing by. That's going to become your coefficient. All right. Since I'm increasing by positive 4, it's positive 4 times n. And then you're going to add, subtract to kind of fine tune it. So 4 times 1 is -4, but to get to -2, I have to subtract a 6.
Okay. So maybe if we do another example.
5n, so you start with 5n. All right, if I'm subtracting 3 every time, -3n.
So.
Okay. Well, the 6 is that fine tuning. 4 times 1 is 4, but I really need to get down to -2. So what do I have to do with that to get me down to -2? Go subtract the 6. Let's say look at the next sequence.
So it'd be 3 and.
That's your answer. Well, look at my next sequence. What's happening every time?
It's increasing.
Increasing by 3, increasing by, increasing by.
7.
Ah, this is not a constant increase.
No.
Yeah.
There's a pattern. Like it's a. Increases by 2.
Yeah. Okay, I'm going to tell you guys, anytime you're not increasing by the same rate, whether you're multiplying or dividing, this goes into exponential. Okay? So which means you're probably end up having an n squared involved. Okay, but again, this is term 1, 2, 3, 4. a little more difficult. So let's start off with n squared. What's 1 squared?
1.
Minus 5. All right, now how do we go from 1 to get to minus 5?
Subtract 5.
Minus 6, right? Okay. So let's see if that works. What's 2 squared? 4. 4 minus 6 is -2. Does that match? Okay, 3 squared. 9 minus 6. Does that match? Okay. So guys, again, this is kind of important when we make this note. When you're increasing by the same rate, you're going to have this setup. Okay, it's called a linear increase. When you're not increasing by the same rate, you're probably going to have some type of an exponent. So n squared is usually a good place to start.
So, would we just do regular n squared?
I would always start with n squared and try to manipulate from there. All right, so let's take a look at example 1 again. Describe the pattern.
So you're subtracting by
What are we doing every time?
subtracting by 3.
We're subtracting 3. That's all you gotta say. So minus 3. We're subtracting 3. What's happening on number 2?
Increasing by 4.
Multiplying by 2.
See.
Okay, number 3, write a recursive formula for the sequence and then find the next term. Okay guys, again, recursive formula, you have to have the previous term in order to get the next term.
Measure this one?
Sure, sir.
Okay, so to get from -2 to -1, you increase by 1,
Okay.
and it's a constant
Uh-huh.
increase, so it'd be like 1n.
So now, Sam, what type of formula are we trying to make here?
Recursive.
And recursive formulas always have the same setup.
So
It's a sub n equals, so the next term equals, that's always going to be in reference to the previous term. Okay, so you're always going to have an a sub n and an a sub n equals 1.
okay, so b plus 1.
So we're just going to take that and we're going to add 1 to the previous term. And then you always have to give it the a sub 1 with a sub 1 equals what? What does a sub 1 equal?
1.
Nope.
Um,
That's your recursive formula.
I don't
Could you
think
repeat
this-
that whole thing?
Yep. Okay. So the format for recursive is almost always the same. You're always going to have first the a sub n. Okay, that's always going to be the first thing you're going to have. A sub n equals. Then you're always going to have on the other side this n sub minus 1. Okay, and what that's basically saying, that's your previous term, right? Sometimes you might have a coefficient out front. It might be 3 times the previous term, adding 1. But you're always going to have this. That's why they're written in black. Okay, and then you have your adjustments. Either I'm going to have a coefficient, or I'm just going to have them adding to it. In this case, since we're increasing by 1, that's the plus 1. So a sub n equals previous term plus 1, comma, again, it's written in black. This is going to be your template. With a sub 1 equal to, what's our first term? And we're done. Okay? So the black's there because that's your template. All you're doing is filling in the holes. Okay? So when I look at example 4, we use the same template. We'll put this in black. So a sub n equals a sub n minus 1. I'm leaving a space in case we need to throw a coefficient in there. Alright? Now, how much am I increasing by every time?
You're decreasing.
Decreasing by what? By
5.
5. So that's a minus 5. Minus 5, minus 5. So a sub n minus 1, minus 5. Okay, go back to my template, comma, with a sub 1 equal to
6.
6. There you go.
So that's the answer.
That would be that whole line is your answer.
So that's our formula.
Do we find this to find
Can we-
this term?
Find the next term. Good. So what term comes after 9 or negative 9?
Negative 14. How do you do that using that formula?
So
Like, I guess that's the.
if you're going to use
connection.
this formula, you would actually have to go in and, all right, we'll kind of show you the long way here. This is 1, 2, 3, 4. This is the 4th term, right?
Yeah.
So I'm going to kind of jump ahead a little bit. We're going to say a sub 4 is equal to negative 9. What this is saying is that a sub 5, which is the next term, is a sub 4, the previous term, minus 5. So negative 9 minus 5, negative 14. So that's how you do that.
Okay.
Okay, explicit. What are we adding everything by on number 5?
Increasing by 3.
By 3. So now remember, explicit is where you build a jump. You're not dealing with the a sub n minus 1 anymore. So we're going to jump. So this is where you're going to take your common difference. How much am I adding by every time? 3. That becomes your coefficient.
So it'd
3
be
times n. Okay,
Plus.
now make your adjustments.
plus 1.
Plus 1. Well, take 3. All right, this is term 1, term 2, term 3, term 4, right? Let's do term 3. 3 times 3 is 9. How do I get to 10?
Plus 1.
Plus the 1. You make that final adjustment. Think of it as just having these dials where you're kind of zeroing in on it. What do I need to do to get to get to where I need to be? Okay, next question is to do what?
Like A, well,
So a sub 12. What that tells you to do is take 12 and plug it in for what?
And
Put it in for 3. So 3 times 12 plus 1. 36 plus 1 is.
36.
Okay, that's the beauty of the explicit formula. It allows you to go to any term very quickly. Notice I didn't have to do all previous 11. We'll go right to 12. Notice 37. All right, number 6. Are we increasing at the same rate?
No.
Nope. So what should we start off with?
I don't know.
Remember this? Think about it earlier. If we're not increasing at the same rate,
Oh, so
it's going to be n squared. So try that. N squared. Again, we're at term 1, term 2, term 3, term 4, term 5. Let's make sure we're on the right path.
so n squared plus
Plus what?
2,
What's 3 squared?
9 plus 1.
So does that work?
Yeah.
5 squared is
25.
25 plus 1 is 26. Does that work for us?
Yeah.
Okay, so that's your formula. And then a sub 12, plug it in. 12 squared plus 1. 145. Okay, you guys had 2 homework assignments tonight.
This is so much.